Hello, my name is Frederick Acuna. Behind the camera today is my partner Xinghui Yu. Together we make up Team 6 of Robotics Lab, and today we'd like to talk to you a little bit about our Valentine's Day midterm project. So the objective of today's lab is to have our robot autonomously arrange different types of Valentine's Day candy into their own separate piles. This would come to be done using the robot's touch and color sensors that will be used to interact and navigate through its environment. Now let's go in for a closer look.
So Frederick, what addition to the original robot car did you make to complete this project?
Okay, so the two major adjustments made to the robot involved installing a trap onto the robot, which would be used to collect these particular boxes of candy in its center, as well as placing the touch and color sensors at a unique location at the front of the robot to serve as a guide in interacting with the environment. The trap itself was used by extending the arms that were the original placeholders for each sensor. So the touch sensor went on this arm back here. The color sensor went on the opposite side over here. So what we ended up doing is we extended it using a couple of Lego pieces, as well as adding a center strut to the center, which would then be used to house the new location of our touch and color sensors. This design would also restrict access to the particular types of candy that we were trying to trap in the middle, namely these pink boxes. Only the pink boxes would have enough clearance to go into the trap, while these hearts, no matter what angle you put them in through, they are not going to go through.
So next question, what was the approach in coming up with this design?
So our strategy involved exploiting the candy's natural shape, the shape of this box in particular, by using the raw RGB data of our color sensor. We programmed our sensor to be able to detect any object in the environment and be able to differentiate this colored box from everything else in the environment. This colored box would be the only thing that would be allowed to go through into the trap zone, regardless of shape or color. To account for the walls in the arena, we also installed a touch sensor in which, when this sensor would go off, the robot would back up and go into another direction, similar to how the color sensor would work if it would pick up any other color other than this pink box, which would be move back and go in another direction while ignoring the object that's in front of it. So as you could see here, this is footage of our robot in action. And right out of the gate, it seems to be doing a pretty good job sorting those pink boxes of candy. The robot was originally designed to seek out those pink boxes in particular and ignore every other piece of candy in front of it. However, the color sensor, as it would seem, would not be reliable enough to carry out that task. In some instances, the sensor would even turn away from the pink boxes or even ignore the hearts that are in front of it, which are the objects that the program was designed to allow the robot to avoid. However, one thing that we could note that is a success for this robot would be the position of the touch sensor. The touch sensor, I believe we added it pretty late into the design process. We wanted to have just an extra fail-safe to account for the walls in the arena, particularly the black walls that we felt the color sensor would have a very difficult time picking up and accounting for on its own. However, the touch sensor, surprisingly enough, was much more reliable during the final test than it was even during the initial design phase of our robot. So that concludes our presentation of Team 6. Thank you very much for your time.